Kia ora tātou. Now, we've got data in our dashboard here. However, this data is not stored in any form of database. So if our Pi goes off or anything like that, then there's no way of getting this data back. It's just accumulated in the dashboard and that's it. So what we really need is we need a database. And we're going to have a look at something called InfluxdB. And InfluxdB sits on port 8086 of our Pi. And let's get into it and see what you need to do. InfluxdB is a time series based database. I'll explain what that means. And data is stored in measurements and inside databases. So we'll unpack all of that sort of information. And first of all, you need to install it. So to do that, you just do it through the dietpy software, sudo dietpy software, and install InfluxdB. Okay, the other thing you really should be installing is sudo apt install InfluxdB client, and this has got some useful things in it as well, for some tools for you. And if you want to read some more about it, a good starting place is the definitive guide to InfluxdB in 2019 on Dev Connected website. Okay, so once you've installed it and it is running, okay, we can open up a terminal window and we can have a look at what's going on inside a database. So here you're in your normal shell, bash shell, and we're going to have a look at running and looking at how we can manipulate and use InfluxdB. So you just start Influx and that gives you the command line interface into Influx. And then what you can do is you can show what databases we've got installed. Now, the standard Influx database comes with an internal database already set up, which you don't have to worry about or manipulate. But I've added two more, environment data and environment average data. So I've shown what databases are, and I need to use a particular database. I'm going to use environment data like this. So now I am using environment database env underscore data. And within a database are numbers of tables, or what were properly called in InfluxdB as measurements. So if I show measurements, it will show me what sort of tables or groupings of measurements there are in my database environment data. Okay, so there's just one called readings at the moment. Okay, so that's the only table within my database. Okay, now I can do things. I can query this. I could go select star from readings. And what that will do is just give me a list of all the readings that are in the database. And currently there's quite a few readings in the database. I wouldn't advise doing this on a database where there were things, you know, significant amounts of readings. But here at the moment, of course, I can use a command to select the count of the amount. And you see the amount is actually a parameter passed to a function called count. So I just want to select that, and I've got 1,338 readings in the database at the moment. Now at the moment these readings are coming in every 5 seconds, so you could assume that actually over a period of time I would have a lot more than 1,338. But and if I keep doing this count routine, you'll ultimately see that this value will reset back. So we're going to look at how data is retained in the database and how we can control how long data is kept in the database for. Let's have a look at the data first of all. So what I'm going to do is I'm going to have a look at just a certain number of readings. So let's take a look at the last say the last 10 readings. Select star from readings, order by time, descending, limit with 10, last 10. So that's just the last 10 readings in my database. And you will see that I have a time field, I have a time, I have an amount, I have a source, a type, and a unit. Okay, so I'm saying that my source is ESP32. Its type is temperature, its amount is 22, and its unit is degrees C, and it came in at this particular time. So I don't have to add the time to the database if I don't want to. I can add it as a field to add. However, it's automatically inserted into the database when I write a value into it. Okay, now I want to unpack some of the way of writing into this and what it looks like. So let's just go to Node-RED and have a look and see what Node-RED is looking like at the moment. So here I've got what we looked at in the last video, which was the gauges. But now also what we've got is we've got the data coming in from our MQTT broker on anything / temperature and feeding it into a function. And in this function we build a JavaScript object. I'll talk about that. And then it is put into a special formatted way of expressing the command that's going to insert the data into the database, and then there's an HTTP request to actually insert the data into the database. So there's a lot of interesting things here to unpick, and you could start at any particular point. What I'm going to start with first is actually let's have a look at how we insert some data into the database ourselves if we wanted to stick it in manually. Okay, so to do that, what I would do is I would type in something like this, insert this value here. So I'm going to copy that and I'm going to type it in here. Okay, now what this is doing is it's going to send a value into a measurement or a table called readings _ 5-minute average. Now I could call this whatever I like, but I'm actually going to give this a value. I'm going to call it not readings because that's my current one, but I'm just going to call it a table called, or a measurement called temp reading. So I've now inserted a value into temp reading. Let me have a look and see what is in select star from temp reading. Okay, so I have one thing in there, and this is the timestamp it came in at. Okay, let's copy that timestamp and go and have a look at what it looks like in our epoch converter. Okay, so whoops, there we go. So I go to here and I type that in there, Control V and timestamp. Okay, so it's saying Saturday 25th of July at 11:54 a.m. Okay, so that's my time zone, and you'll notice that it's in nanoseconds. So the data that is added to a database in InfluxdB is added at a nanosecond increment. Okay, so if I wiped off the last 3 digits of this, then it would be a microsecond increment. Okay, and if I took another 3 values off that, then it would be at milliseconds, which is the normal Unix time and date function. Okay, but it's not like that at all. It's done not in milliseconds or even microseconds, but in nanoseconds, and that's something you can change if you want to in the settings for InfluxdB. Okay, we're not going to bother about that. The next thing is that the amount came in, the source came in, the type came in, the unit came in. Now these are actually 4 different things, but actually there are 2 categories of things here. There are tags and there are fields. Okay, so first of all I need to know what are tags and what are fields. So if I go this command and I go show, oops, just right click on that. No, it's not doing it. Let's try that again. Show tag keys. Okay, let's copy that. Show tag keys. Okay, the tag keys in temp reading, which is the table or measure I'm working on at the moment, source and type. So source and type are tags, and this goes for the main readings database as well. If I want to show what are fields, I can see which are fields. Show field keys. Okay, so show field keys, I've got amount and unit. So what we can see here is that amount and unit are fields. Okay, and amount has a type of float, and unit degrees C has a type of string. Okay, so it's really crucial that you understand that within a measurement or table, things are either tags or fields. Okay, so how do we actually insert something into the database? So what I'm going to do is I'm going to look at inserting this here, and I'll just type that string again. So when we type this in, you need to be really careful about spaces and commas. Okay, so let's have a look at over here what I've done is I've colored these in. So readings 5-minute average. In this case, I've put in readings 5-minute average, but I didn't use that field. Let me go back to the one that I did use, which was temp readings. Temp reading. Okay, so temp reading is the name of the measurement or the table that we're going to write this data into. Now that's followed by a comma, and then after that there is no space, and this is then followed by the tags. Okay, so type is a tag, and the actual data that's in that tag is called temperature. So if I look back up here, you can see that the tag type has the value temperature at the moment. That's followed by a comma and no spaces, and the new tag there is source, and in this case it's ESP32. So this is the source, and its value is ESP32. Then there is a space, no comma, then there is a space between there and there, and so what you've got now is you've got the field, which is amount equals 23.4. So there's a field which is amount, and it's got a value of 23.4, and that's followed by a comma with no space, and that is unit. So that's another field, and its value is degrees C. So that's unit with degrees C. So it's really important that you follow quite clearly and understand the fact that there are commas in certain places and spaces in certain places, and know that comma comes after your measurement, and then we're followed by no spaces, and we've got commas right through to the end of all the tags, and then there's a space, and then there's comma separating the different fields. Okay, very important to get that. Now the next thing to get is the fact that the tag is type, but its data is temperature. Now this is defaults into a text type of data. Okay, so it's text, and the same with ESP32. So tag is type, and its data is temperature. Source is the next tag, and its type, sorry, its tag is source, and its data is ESP32. But you don't have to put these in quotation marks. Okay, it's defaults to the fact that they are strings, and it will store them as strings. And you can see that down here, that what it's done is it has stored them in the database. But when you go show the tag keys, it won't tell you what types they are. But when you go to the field, it will tell you what types they are. So amount is actually of type float, and unit is type string. So here we've got amount, and it has 23.4 as the amount, and there are no quotation marks, which means that it's going to insert it as a float type value. Okay. Now unit as a field has a value of degrees C, but I've put that in quotation marks because I want it to recognize it as a string. Okay, now there are booleans as well and other things, but it's really important that you understand that if you're going to put strings into a field, they must be quoted, and you don't and do not, but don't have a choice, you do not actually quote strings that are going into tags. Okay, so it's really important you get that information clear in your own head as to exactly what is going on with an insertion, because we need that later on for doing automatic insertions. Right, so that's how you insert data into a database. Now I've said already that the data here, select count, we're at 753 at the moment. Okay, now previously when we did this, we had a higher number. We were at 1338, 1342. And there's something else about our database which we can add, which is our retention policy. And what that means is we can keep data coming into the database as much and as often as we want to, but we will throw it away after a certain period of time. So let's just have a look to see what we've got here. I've got a little image here of what is happening in InfluxdB at the moment. So what I've got is inside InfluxdB, I have two databases, one called environment data and one called environment average data. Each one of those databases has got a single measurement or table at the moment, just the one. Okay, this one is called readings, and this one over here is called, well, we're going to have a look at it and see what's going on soon with that. Also what we have is we have a retention policy called hour, which will retain the data in our database for 1 hour. Now let's have a look at a retention policy. So what I'm going to do is I want to show the retention policies for my database environment data. Okay, so I'm just going to copy that in there, and it will tell me that I have 2 retention policies on the data which is in my environment database at the moment. The first one of those is an auto-generated one, which is at 0 seconds, which means it keeps all data. If you want to change this so that it defaults to something else when you create a database, you can do that through the setup file, the configuration file for InfluxdB. Now, the other one I've created is called hour, and its duration is 1 hour. So what will happen is the data in my database will last for no more than an hour, okay? Or an hour or more. So let's just have a look at what actually is happening in our database at the moment, because what I did was I showed a count of what's going on, and it's up to 778. Now what that means is that if I'm inputting data at the rate of 5 seconds, a data point every 5 seconds, into a database that has a 1 hour retention policy, then I would expect there to be 720 readings if it kept just the last hour of data. But actually what it does is it keeps at least 1 hour data, okay? And every now and again when it does a update of this, it will delete data which is older than 1 hour. So the number here will never be less than 720, but will obviously be more than 720, and it will continue to increase, and it will get pretty close to 2 hours worth of data in the database, in that measurement or table within the database before it deletes it. Now otherwise, if I collected 5-second data over a period of a year, then I would have a huge amount of data going into my database, okay? That would be completely unsatisfactory. So what we often do with a database like this is we keep the current data, say every 5 seconds, but then after that what we do is we aggregate the data somehow, average it or count it or something like that, and we might stick that into another table or measurement. And what I've done is I've created a second database, environment average data, right? And what I have in here is another table, okay? So what I've got is I've got 2 databases. So what I'm going to do is open up the second database. So in here I'm going to start up Influx. Command line again. So I've got 2. This one here is looking at readings inside environment data. This one here I'm going to use my second database, environment average data, right? And now I want to show what measurements are available in that. Measurements, okay. So I've got readings. If I do show measurements in this one, show measurements. Okay, I've got readings and temp reading, which is the one I just created to play with an injection of data. And down here I've got readings 5-minute average. So what I've got is 2 separate databases, right? And each one of them is, well, this one's got a second little table in it, but both of them have got one main table, readings, and in this one it is called readings 5-minute average. And both of them have retention policies. So if I go to show retention policies on this, so we know what the retention policies are on this. I can just take this command for retention policies, show retention policies on environment data. It's got a retention policy of hour. Down here on environment average data, what I've got is a retention policy of hour as well. So for test purposes at the moment, I've just got both databases working with 1 hour retention. This second one here I could set with like a 1 year retention, so it kept my average over a period of for a whole year, but threw away the data, the raw data, 5-second data every hour. Okay, so what we're going to do is we're going to create what's called a continuous query, which will take an average of the 5-minute data and put it over into this database. And so a continuous query is quite an important thing. What I've got here is this is the continuous query. In fact, it comes as, you have to enter it as one line. So what I've got here is this is how you would enter it as one line. You just copy and paste this. Okay, and now I'm going to unpack what that means, okay? So what we're going to do is we're going to create a continuous query. We're going to call it temporary average on 5 minutes. So this is going to go into this database here, this query, and what it will do is run on this table or measurement and poke the average into this table in this database. So let's just see what show continuous query, for instance, would reveal about this query that's here at the moment. So I've already done this. So there it is. There's my continuous query. I don't have any continuous queries on the second database, just on the first one, and it's called temperature average 5 minute. That's what it's called, and this is the actual query itself. Okay, this is what you would type in. So let's unpick what that means. So create continuous query. This is the name of it. On, and this is the database that you are creating it on. So I'm creating continuous query on this database. Okay. And then what we're going to do is we begin and we have an end for the actual query that will be run, okay? And the query that will be run is to select the mean amount, or the mean of amount. And we know what amount is. Amount is all of these temperature actual readings here. So I want to take the mean of that and I want to poke it into a value called mean amount, okay? And then I want to put it into this database here, okay? So that's the database environment average data dot year dot readings dot 5 minute average. Now I don't actually have a year here yet because a year would be a retention policy of 1 year, but it's going to poke it into this database anyway, okay? And then it's going to get it the data from readings, so that's from, it's going to get it from readings, and it's going to group it by 5 minute intervals and do the average and then poke it into this database. So if I go into this database, this continuous query is running. If I have select star, so I'm selecting stuff from this measurement here, select star from, and the measurement name here is readings underscore 5 minute average, I think. There we go, there it is there, okay? So this table now has just these readings in it, okay? It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 readings in it at the moment. And every 5 minutes it will get a new reading, okay? And that reading will be an average of 5 minute groupings here. So this is really complex, and that's why I drew the diagram so that you could see what's going on. 2 databases, 2 measurements or tables, one in each. What this is doing is this database currently has a retention policy of 1 hour. This one also has a retention policy of 1 hour for the moment, just so that I can use it for testing purposes, but I would bump this up and make it a retention policy of 1 year, so I keep 1 year average, okay? And then what we do is we run a continuous query on this measurement here and take those and stick them into this measurement in this database. So I know it's a little bit convoluted, and I hope as I've stumbled over this that you've been able to make sense of it, okay? It isn't easy, okay? This is complex, but I hope this is a good little starter for you on getting some data displayed, getting some data into a database, okay? And being able to just understand that you write queries on a database, and then you can run continuous queries and you can have retention policies. And this is a special type of database, a time series one, okay? It's not something that you would find in necessarily an ordinary database like MySQL. So that, because it adds the time automatically to each value or each reading as it comes in. So hopefully it's a bit of a kickstart, and I hope you found this useful. Cheers.